Hello everyone, today we'll be looking at question number 18 on SAT practice test number 3, Math No Calculator section. So here we have two isosceles triangles shown above, 1, 2. If 180 minus z equals 2y and y equals 75, what is the value of x? So now we'll go into a step-by-step analysis of how to solve this problem. So step 1. So you have 180 minus z equals 2y, and then you have y equals 75. Both are given. So we're going to use a little bit of substitution and put in the y equals 75 into the 2y. So that gives you 180 minus z equals 2 times the value of y, which is 75. 2 times 75 equals 150. So you get an initial function of 180 minus z equals 150. On to step 2. So we move z to one side to get z equals negative 150 plus 180. And how we did that was, so when z would be moving to the right of the equal sign, it would lose this negative sign, so that would become z. And then we would be moving 150 to the left, which gives you 180 minus 150, which is also 30. So you have z equals 30. And we have this value right here, z equals 30. Now the next step may get a little confusing, so it's better to follow along. So we have this figure here. We have this is your first triangle, this is your second triangle. What we're going to do is we're not going to take a look at this side. We're going to mainly take a look at this side, because we have to find x degrees anyways. So when we shift this specific shape over, we get an upright sort of isosceles triangle with x to the right of the triangle. And isosceles properties tell us that the base angles right here and right here of the two equal or congruent sides would also be equal, as this angle would have to produce the same side as this angle for it to produce an equivalent side. So what we can do is we can do the sum of all angles of a triangle, which equals 180, equals z, which is our initial value, plus 2 times a base angle. And why we're doing that is we already know that these two base angles are equal, so we can just take one value and times it by 2, as there are two of them, plus the z, which would give us 180. So when we put in our z value of 30, we get 180 equals 30 plus 2 times the base angle. Then we just move 30 to the left hand side of the equal sign, which gives you 180 minus 30, which is 150, equals 2 times the base angle. Then to get rid of the 2, we would have to divide both sides by 2 itself. So then we would do 150 divided by 2 and 2 times the base angle divided by 2. And that would leave us with 150 divided by 2, or 75 degrees. So one base angle equals 75 degrees. Moving on to step number 4. Since the base angle equals 75 degrees, we have a figure that somewhat looks like this. If you extend this line and bring it back down, that's our isosceles triangle, but we don't necessarily need that information. We just needed this angle. Why? Because we know that this is a straight line. So the full angle measure should be 180 degrees, which is also another geometry given factor. So since we only have a little bit of a sector right here, we will do 180, which is the entire angle, minus that little sector that we have, 75, to get x, 105 degrees. So thus, x would equal 105 degrees. And we can envision that again here. Give me 1 second. We can envision that one right here with z equal to 30, one of the base angles equals 75, and you having that straight line. So the 180 minus this 75 right here would give you 105. So the value of x is 105. Thank you.